Good morning all, my name is Thavinnesh Rajendran. Today I would like to talk about vacuum-assisted additive manufacturing to improve mechanical properties of recycled thermoplastic polymers. This research is supervised by Professor Dr. Shahjahan bin Maiden and co-supervised by Dr. Rahima. First thing first, to understand the title better, we must raise several questions. What is 3D printer? What is vacuum? What is material waste? What is the application field in 3D printing? And so on. First of all, three-dimensional or 3D printing is an additive manufacturing process that creates a physical object from digital design. The process works by laying down thin layers of material in form of liquid or powder plastic, metal or cement, then fusing them by layers together. Next, what is vacuum? Well, the term vacuum is used to describe the zone of pressure below atmospheric pressure. Vacuum is negative gauge pressure, usually referred to the existing standard barometric pressure where the equipment will operate. Following on the introduction, next is problem statement. According to Song and Talenko, additive manufacturing has been rapid growth over the last decade. Despite its growth, its ability to build functional parts with complex geometrical shape, the process creates a large amount of waste material due to printing, machine, and human errors, as the most of the standard or open source FDM printer is used by inexperienced users. The amount of failed printing is about 2.2 times the predicted amount of waste produced. According to Santos, the amount of waste polymer material from 3D printing should be reduced by recycling it. However, notable changes in polymer characteristics were observed reflected by degradation in the mechanical properties after recycling it. According to Paiva, the best to our knowledge, little evidence is available from the literature about experimental methodology integrating vacuum to improve the bonding between the fused layer of recycled polymer to enhance its mechanical property to address the polymeric material degradation in the context of open source additive manufacturing. Next was objective. The objective of the research are as follows. First of all, to evaluate the feasibility of applying vacuum pressure when the printing of the test sample to study the influence of the fused layer of recycled polymer and their mechanical properties. Second, to determine the optimum process parameter, namely vacuum pressure, layer thickness, and build orientation. Third, to examine the microstructure of the standard and the recycled specimen sample subjected to vacuum pressure. Lastly, to compare and evaluate the standard and recycled specimen that subjected to vacuum pressure. Moving on to literature review, we'll be talking about additive manufacturing. Additive manufacturing, as we told earlier, is a process of joining material to make parts from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing and formatting manufacturing methodologies. All the additive manufacturing techniques share similar 8 basic steps, which are step 1 are conceptualization and CAD. First, a product look and purpose must be analyzed. Conceptualization can be verbal, relative, sketchy, or model-based. Model description must be typed into computer for these reasons. Step 2, which is conversion to STL file. Most CAD programs automated to conversion to STL procedure, although errors might occur during this stage. Following that, step 3 are transfer to additive manufacturing and STL file manipulation. Next, step 4 is machine setup. Step 5 are build. Step 6 is removal and cleanup. Last but not least, step 7, which is post-process. Post-process is the end finishing of item for use. This may entail polishing, sanding, or coating, this phase is application specific. Some applications require minimal post-processing, taking advantage of the speed. Lastly, application, which is post-processing, makes pieces usable for this application. Let's talk about material and vacuum. Well, for material, polymers are found in everything from packaging, automobile, furniture, micro-device, and even biomedical components. According to Goossens, massive production and extensive use of plastic have resulted in several unprecedented issues relating to disposal and recycling. For vacuum, American Vacuum Society defines a vacuum as gas-filled space at a density below atmospheric pressure for practical purpose. The benefit of vacuum-assisted die casting are such as rejection due to porosity being virtually eliminated, excellent surface quality ensuring the product density and strength increasing has been claimed to improve. Next is methodology. In this part, we are explaining about several phases. Phase 1 is conceptual and planning. First, the literature review will be carried out to study the fundamental knowledge on the concept, theory, practice in the particular concerning of the use of vacuum system and the post-processing of additive manufacturing specimen. Based on the thorough research, preliminary proposed technical solution on the design criteria will be made. The research study will be performed under planning and purchasing stage of necessary material and accessories, building the vacuum system integrated with desktop printer and consider all the practical procedure. Lastly, preparing the detail of the experimental setup to print specimen using the vacuum assisted printing. For phase 2, test rig fabrication and preliminary testing. A test rig will be built to serve as the platform for the first test experimental trial. Moving on to the phase 3, which is experimental and analysis of objective 1. The phase 3 focuses on analyze the effect of vacuum pressure and printing process parameter on the surface finish of the printed specimen. A set of optimized parameters are expected from this activity. For phase 4, experimental and analysis for objective 2. Using the optimized vacuum pressure and printing parameter from the phase 3, a series of second printing of specimen will be performed. The tensile strength and microstructure of the specimen will be measured. Lastly, for phase 5, which is experimental and analysis of objective 3, the result obtained from phase 4 will be compared with non-vacuum assisted specimen. What we can expect from this research is the ABS specimen is more likely to be impacted by vacuum pressure. The ABS and PLA samples' compressive strengths can be significantly increased when the vacuum pressure is applied. As well, for conclusion, the differences between sample produced in 3D printer with vacuum pressure and sample printed with atmospheric pressure may be observed. Lastly, this Gantt chart represents my entire timeline of my research. Thank you.